Okay, so we're gonna start off by reading out the problem. It says organisms A and B start out with the same population size. Organism A's population size doubles every day. After 5 days, the population stops growing, and a virus cuts the population in half every day for 3 days. Organism B's population grows at the same rate, but is not infected by the virus. So after 8 days, how much larger is organism B's population than organism A's? To find that out, we're going to do the problems that they give you. So like 1, 2, 3, and 4. And we'll do them piece by piece, and that'll give you the last answer. So for your first answer here, they're asking, by what factor, whoops, God, I wrote on the question. Oh, okay, there we go. By what factor does organism's A population grow in the first 5 days? So express your answer as an exponential expression. Okay, first off, you need to know what an exponential expression is. Okay, exponential expression. So usually when you do an exponential expression, you have some sort of number. Let's say it's like 2. Okay, so we'll write 2 here. And it's to some sort of power, so pick anything like 2 to the 5, right? So what that means, let's do that extra top. So what that means, the way this is set up is like, this is called the base. And this is called your power. Power. Come on, write for me. There we go. I'm writing with my finger, that's why it's hard. Okay, so you have something called the base, and you have something called the power. That's just how exponential expressions are set up, okay? Now to answer this question, you need to know, it says by what factor does organism A's population grow? The population could be anything. They don't tell you in the question, right? So if they don't tell you what the population is, it's probably not important. So it could be like, it could start off with 2, it could be 5, it could be 6, it could be 7, right? There could be like 100 rabbits. So because it could be anything, we will say that the population, we'll call it X, okay? So that'll be the initial population. We'll say it's X. And remember, it's doubling every single day, right? So this X, this is day 0. I have like X amount of bunnies, right? After 1 day, I double. So I multiply by 2, right? So that's the first day. After the second day, multiplying by another 2. And the third day, same thing. Same thing happens on the third day. Multiply by another 2. Same thing on the fourth day. Multiply by another 2. Let me get rid of this here. And on the fifth day, same thing, I multiply by another 2. There's a shortcut for saying what this is, and that's why we use exponents. So when we multiply the same number by itself a lot of times, that's when we use exponents, okay? So look at the number that we're multiplying by itself. This 2, right? And how many times does this 2 come up? It comes up 1, 2, 3, 4, 5 times. So the way that we do that, this right here, all these 2's, that's the same thing as saying 2 to the 5. 2 to the 5. And that's our factor of growth. Remember, we still have to multiply the original population, which is X. Okay? And so that means this is our answer. X times 2 to the 5. 2 to the 5 is your the factor by which the population grows. Okay, so not too bad. Remember, multiplying that same number over and over again You count how many times it shows up. 1, 2, 3, 4, 5. Then we put it to the 5th power. Okay? So the next one. The expression showing organisms A decrease in population over the next 3 days is 1/2 to the 3rd. This can also be written as 2 to the minus 1 to the 3rd. Write 2 to the minus 1 to the 3rd with the same base, but no exponent. Okay, so what we need to know here, anytime you have a number to a negative power, I'll show you what happens. So let's say I have 2, right? I have 2 to the minus 1 power. All that does is you put a 1, you put a fraction, and you write this same thing, and you just put it down here, but without the minus. Okay? So if I had like 3 to the negative 3, all that means is that I'm doing, again, I have to do 1 over 3, and we bring that power, but it's not negative. Okay, so that's all we're doing. So let me delete all this here. Come on, please delete, delete, delete. Hang on, it's taking a while. Technical difficulties. This is not deleting, I'm sorry. Let me just move up the other problems down real quick. Oh God, sorry. Fucking goddamn it. Okay, we're deleting now, we're good. So anything to the negative power, you just put it underneath a 1. Okay, so we'll go over this problem. So it's saying 2 to the minus 1, 2 to the minus 1. Remember, what does that do? All it does, put a 1, 2 to the 1, right? Things get a little bit complicated when you have powers to powers. Okay, so if I have 2 to the minus 1 to the 3rd power, what you have to do is you have to take this 3 and you have to multiply it. You have to multiply it by that minus 1. And what that should get you, what is 3 times negative 1? Give you a little bit of a second to answer that while I erase. 3 times negative 1 is negative 3, right? And remember, anytime you have a power to a power, you multiply those powers. So 2 to the negative 1 to the 3 is 3. Take that 3, multiply by that negative 1, and you get 2 to the negative 3. 2 to the negative 3. This is true for everything, but this will be your answer here. 2 to the negative 3. This is your answer. 2 to the minus 3. That's your answer. Okay, and I'm just going to give you a little bit more examples of what else could come up like that. Let me just erase real quick. Sorry, this is taking a little bit. So if I have if I have 3 to the 3rd power to the 2nd power, what you would have to do is you take this 2, see that 3, you multiply that. And then what you end up with is 3 to the 6th power. Because you know why? Because 2 times 3 is 6. So 3 to the 6th power. Okay. So let's go on to the next one. This will be your answer for number 2, though. Just make sure. Yeah. Oh, and as a bonus question, right? They're not making you do this, but this is the same thing as saying what? Remember, anything to a negative power, that means you take all this, but you just put it underneath a 1. That means bring that 2 to the 3. It's the same thing. Both of those are the same thing. Okay. Okay, so the next one, number 3, says by combining the increase and decrease, find an exponential expression for the total change in organism's population after 8 days. So let's see, right? Our initial population, we'll say it's X, right? It could be anything. X could be 100, 200, blah, blah, blah. They don't tell us. That's why it'll be X. Remember, after 1 day, we doubled in size, times 2, right? So that's the first day. And the second day, we also multiplied by 2. We doubled in size. Same thing for the third day, and the fourth day, and the fifth day. But then on the 6th day, we got infected by a virus, right? And that means they're saying our population got cut in half after we got infected. So every day that we're infected by our virus, we're multiplying everything by 1/2. That means, and please ask me later if you don't understand this, okay? So remember, we're counting. So after first day, we multiply by 2. Second day, 2. Third day, fourth day, fifth day, 6th day, we got infected, right? So we're going to multiply by 1/2 because they told us that's what happens when we get infected. And same thing for the 7th day and the 8th day. Okay? And, okay, that's what happens, but this is not how you should be writing your answers. Okay? This is just for us to, think about the story. So, you'll notice that if you have to remember your fractions, okay? 2, if I take 2 and I multiply it by 1/2, this actually equals 2 over 2, which means 1. And I'll show you how I do that, okay? This is the same thing, 2 times 1/2. This here is the same thing as saying 2 over 1 times 1 over 2. Anytime you have a whole number, you're going to put it over 1. And this is useful because when you multiply fractions, what you're doing is you're multiplying the top right across, and you're multiplying the bottom right across, okay? 2 times 1 is 2. 2 times 1 is 2. And remember, anything over itself is 1. See that? So, let's see here. I gotta continue erasing. More problems. Let's see. Technical difficulties. Cool. So the reason we have to know that is because every time we see a 2, and a 1/2, we know that when they multiply, both of them give us the number 1, right? And so how many 2s and 1/2s do we have? We have 3 1/2s, and we have 3 2s, right? So if I bring this 1/2 and and I multiply it by this 2 here, bring those together, and I multiply them, they give me 1, right? So basically, every 2 crosses out a 1/2. See that? Blah. And what we end up with is just this here. So x times 2 times 2. But remember, we could write this as an exponent. So we could write x times 2. But how many times does 2 show up? It shows up 1, 2 times. And that's our answer. Okay. So by combining the increase and decrease, find an exponential expression that shows us what happens after 8 days. See how they cancel each other out? And you just count up how many 2's are left and you put it to that power. So x is the original population. 2 is how many times it doubles, but it doubles 2 times because 2 days. So number 4, they're asking us to write an exponential expression showing organism B's growth over the same 8 days. Remember what I told you, right? Let's go back up. Let's go back up actually. It says organism A and organism B start out with the same population. So that's with X. And it never gets infected by a virus. So after the first day, it doubles in size. After the second day, it doubles in size. Checking my phone real quick. After the third day, doubles in size, and the fourth day doubles, fifth day doubles, sixth day doubles, seventh day doubles, all the way down to the 8th day to another 2 over there. See that? So again, we just count up those 2's. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, right? We doubled over 8 days. So remember, I write my original population to the 2, but how many 2's are there? 1, 2, 3, 4, 5, 6, 7, 8. Right? X times 2 to the 8, and that's your answer for number 4. And for number 5, we know that for population B, our population grew by 2 to the 8th times X, right? And for population A, remember after 5 days, it was X times 2 to the 5, but after the 3 days, after like 3 more days, it got halved 3 times, and so we were left with 2 times 2 to the X, right? Remember, go back to number 3. That's actually the total amount that population A grew over the 8 days. So population B is that. Population B is right there. Population A is right there. Okay. How the heck do we find out how much bigger population B is compared to population A? To find that out, we have to divide. We have to divide these numbers by each other. So 2 to the 8th x, 2 to the 8th x over 2 to the 2x. And when you divide things with variables like this, you cancel out anything that looks the same, right? So I'm just going to expand it to show you what these look like, okay? So 2 to the 8th is just 8 2's. So 2 times 2 times 2 times 2 times 2 times 2 2, 3, 4, 5, 6 times 2 times 2, 6, 7, 8 times x all over 2 times 2 times x. Anytime you're multiplying things, right, as long as everything is being multiplied, when you do division, you could cancel anything that looks the same top and bottom. So these x's, since they're the same top and bottom, you cancel. These you count how many 2's can cancel out. There's 1, 2 here, and there's 1, 2 there. There's 1, 2 here, and there's 1, 2 there. Which means how many 2's are left? 1, 2, 3, 4, 5, 6. So population B is actually 2 to the 6 times 2 to the 6 times greater. Sorry, I'm typing with my fingers and it's really hard. Greater times than population. Oh my god. Then A, okay? So B is, oh my freaking god. B is 2 to the 6 times greater than population A. I had to do this really fast because it's really late. I would have explained more, but please, too, if you need more to answer any questions.